Our next speaker is Nicolò, and he's going to tell us about how he accidentally built a neural network. So please welcome Nicolò, and the stage is yours.
Thank you. Hey everyone, I'm Nicolò, and today I will show you how I accidentally built a neural network, or at least something that looks awfully like it. And by the end, we'll most likely know how a neural network is shaped and what it should do. But who am I to talk about this? As said, I am Nicolò, and I'm a senior developer at Nebulab, an Italian e-commerce company, after spending like 10 years of my life working in cinema post-production. Totally different story. But here I am. So what do we do at Nebulab? We build custom e-commerce systems, both on Rails, Solidus, and also on Shopify. You may recognize some of the brands up there, the framework laptop manufacturer, Cometeer, MeUndies. Those are US-based brands, but should be pretty famous. I don't know, at least for me. I work with them. So one thing that I want to show you today is the work that we've done for Cometeer. And I want to understand how many of you drink coffee. Okay, I believe a lot of people. So at least if you, I don't know, want to bring something home from this talk, maybe you will know something more about coffee. So there's also that one. So what does Cometeer do? They essentially partner with top roasters, top coffee roasters around the world to bring you one of the best coffees around. And they don't stop at extracting the coffee. They will also flash freeze it under liquid nitrogen, and they will ship it to your doorstep under dry ice. And I'm Italian, so I don't know. I come from the culture of espresso, and like drinking this kind of coffee was a weird experience, but I don't know. It's very good. I very like it. So without further ado, let's dive in. Cometeer has a problem, like a good problem, if you will, because they have lots and lots of products to choose from. And they have many products, many characteristics, many aromas, many things to choose from. And what do you do when you have too much choice? You paralyze, essentially. So what is a solution to this? As Ruby and Rails developers, we are very familiar with the solution they chose. They went omakase. So they decided, okay, we can even let the customers let us choose for them. So if they don't know what to pick from our never-ending or all-encompassing list of products, we can choose for them. And this is the most beginner-friendly product that they sell, which is a box with mixed roast levels, so they can experience lighter coffees, darker coffees, and balanced coffees in one box. So this product is like a fancy physical box, but at the logical level, at the e-commerce level, this box is represented by these 5 products. So it's composed by a light roast, a dark roast, and 3 medium roasts. And this is just a representation of the product that the customer will actually get at their doorstep. This is all virtual. So we have a problem of having these virtual products, and how do we translate these virtual products into physical products, essentially? We need to decide what's the best possible choice for each of these little circles. And the question mark up in the slide is the thing that we are going to talk about today. So how do we translate the virtual, the electric world to the physical one? So how do we actually make a good choice, a good informed choice to send a good product to the customer that they hopefully will like? So Here we will go through a couple of different iterations of this question mark, and maybe the talk title will give you like some sort of hint where we are going. But like the real problem is, how do we make this question mark that we just saw like feel like a proper barista? So like someone that knows you, someone that can pick the correct coffee for you. Maybe they see you today, you are particularly down, this barista can pick you up with the right coffee for you. I mean, hopefully we can get to that level, but we cannot read minds at the moment. So, and I believe that we shouldn't. However, the first implementation of this system was very, very simple. Like every month, someone in the operations team just maintained a huge list, an ordered list of coffees, essentially. So for October, we had maybe this particular selection of coffees because there is also seasonality to take into account. What you extract, the beans that you source in August are way different than the ones that you source in December, and I don't know. It's a complicated word that I don't have the authority to speak about. However, I understand it a little bit better right now. And every month, an operator needed to essentially take a look at the supply chain, understand what was happening, then reorder the coffees, because the first implementation was just a matter of picking this huge list and going through it and seeing essentially what kind of coffees matched the requirements at that moment. So in this slide, we will see like the very, very rough implementation of the algorithm, which is just, I don't know, few lines of Ruby. And it's just a matter of like going through the products, asking for each of them, does it satisfy the requirements? So we are taking a look at an empty slot because each slot needs to be filled to have a complete order. We need to take into account if the requirement of this slot matches the product, so the roast level, the caffeine level, and other requirements. Then we ask, is there enough inventory? Because, of course, inventory disappears in the real world as soon as people buys it. And then we just decide that the first thing that matches all of these, so just a bunch of if everything is true, we just assign it. And when we have enough, because we might have a massive list, when we have enough, we just break out of the loop, and it's not the most elegant thing, but it works. So at the start, we had this particular algorithm, nothing really fancy, and we started to think, okay, how can we make this more personal? We wanted to get a little bit smarter, essentially. And how do we do it? We start thinking, okay, maybe to enforce some variety, we want to enforce some kind of constraints. We thought about this term. And we decided to go with this, like, this is not the real production code that was online, but this is the gist of it. So we started to think, okay, we start by trying. We just try, okay, we enforce these two constraints. We have we want only a coffee for a roaster in the box, so people can see a very colored box, which is color is good. More color is good. And also, we don't want to have the same product twice in the box, because it's not the best to have two of the things when you want to optimize for variety. However, it's not always possible to fulfill these kind of orders in this way, because maybe a customer disliked a particular coffee that would have been chosen in that moment, and you don't want to send a customer someone that they said explicitly, I don't like it, I don't want it. That's bad. So we start like looping through all of these permutations, and we just ask, like, can we find an order that satisfies both of these constraints? If no, let's go to the next one, to the next one, and then at the end, we just try with both constraints relaxed. So basically, we come back to the original version of the algorithm, because the next step is just the previous code with just 2 ifs added. So we are adding more ifs to the statements. And this started to be really painful, essentially, because the moment that you want to add more constraints, you end up with an ever-growing list of ifs. You are hard-coding your ifs to the structure of the code, like the constraints don't really live in the code, shouldn't really live, because the moment that you want to add more, there is more coupling, and it's just bad engineering. Also because you are trying multiple times the same code. However, the implementation was simple enough to understand it and also explain it to stakeholders. Because another part of this story is also explaining these or making the whole decision explicit to stakeholders, because we are consultants and part of the job is also communicating with stakeholders. You need to make them feel safe in the solutions that you propose to them, and also you need to explain them how they work usually, so they can feel empowered to at least have an opinion on them. Not always a good thing, in my opinion, but it helps in selling some solutions at the end. And the most important part is that in this version of the code, the boxes that we were sending out to customers were definitely better, essentially. So we lost a great deal of auditability, because each resulting box wasn't really a clear cut of, oh, why did this coffee end up in this box? It wasn't really that easy to trace back. We didn't have, and I don't think we will ever have event sourcing to understand this. And this planted a little seed, because as us developers right now with the LLM thing, we are releasing a little bit of control to systems that we don't really care about of how they work in their inner workings. And the same thing happened here. So the product team just was happy that the results were way better than before. And okay, this is exactly what I just said. So the harder upgrade here was to actually being able to trace back each decision to the code, or why something was picked. And as you may understand, we decided to go with a rewrite of the system, because this system wasn't really scalable, because they noticed, okay, this is good, but how do we make it more good, more better, more? We want more knobs, more parameters. We want to optimize everything. And so you start rewriting things. And we started to think, okay, how do we do it? We understood that the first part of the code was just a means to filter out products, because we needed to understand, okay, is there enough inventory? Is this product matching the requirements of the slot that we are trying to fill? And stuff like that. So, of course, with the great creativity that comes with being backend developers, we decided to call this part a filtering stage, essentially. So we start with a huge list of products, and for each slot that we are trying to fill, we start by filtering them down with easy and small pieces of logic. So in this case, we are maybe filling for a light roast, and we start eliminating all of the things that aren't a light roast. Then we put another filter, and we want only fully caffeinated coffees, because apparently you can have decaf coffees or coffees with just half the amount of caffeine, a thing that I didn't know of. And then you filter further down with products that are not disliked by the customer, and so on and so forth. You can plug any number of filters in this system. Then you end up maybe with 3 products, 3, 4, 5, 10, I don't know. And you start maybe counting some other conditions. Maybe you want to say, okay, this product is of a roster that's not already in the box. This product is not in the box yet, so it gets maybe 2 votes. One product is only of a different roster, so it gets only 1 vote. Then you may have an arbitrary amount of conditions that you want to check, and essentially you collect votes on each of the products, and you just count which is the winner. However, this strategy had a slight problem because maybe some vote didn't counted more than others, because maybe the product in the box, having the same product in the box is worse than having 2 coffees from the same roaster in the same box, because we want to optimize for variety in this case. And we were starting to think, okay, these conditions are not equal. We need to weight them. We need to start thinking about that not all votes are equal. So we start to think that these votes should have a weight, and this weight should have then a coefficient that we start to multiply things with. And this monstrosity that I am about to show you is essentially the code that ended up sort of in production. Still not the production code, but this is just a schematization of that. And we start with an empty list of products that we want to fill. And for each of the requirements, we run this loop. For every product, for every requirement, we start to think, okay, we have a huge pool of products. We filter it down with all of the filters that we define. Then for each of these filter products, so we have a smaller pool, we start to essentially score them. We start to multiply their weight by a result of parameter multiplication. So we start to think, okay, this product is not in the box, so we multiply it by an arbitrary number. Or this product is already in the box, so we don't multiply it, we multiply it by 1. And we go on like this, for all of the parameters that the product team decided. We start doing it with 20 parameters, and we end up with a list of amplification. These amplifications store essentially what the product is amplified by. So we have an audit trail of all of the things that went into deciding the final score of the product that we wanted to recommend to the customer, essentially, with each result tied to each parameter. So we could actually see what was the result that drove that selection. And at the end, we just picked the top one. And in case we, of course, didn't have a winner, it meant that our product pool was too small, and that was a problem for someone else to fix, not us engineers. So that's great. And in case we have a winner, we just store some metadata on that just to understand, okay, we selected this product, but we had maybe some runners up. And we had the top 3 competing products to the metadata, so we can actually understand, okay, if this wasn't chosen, the next one would have been this one and this one. So we could ask, okay, does this make sense? Yes or no? That question was asked a lot of times. So let's dive in a little bit in an amplifier. What's an amplifier in this particular case? It's a plain old Ruby object, as the rest of the things, and the code is pretty simple. It's just, okay, is the roster in the box? Yes. Multiply by 1. Otherwise, a coefficient, because all amplifiers are initialized with a coefficient. Like if I go back a little bit here, you can see that the amplifier is initialized by the coefficient and the product and whatever, and also other metadata that maybe some amplifiers needs to work. This is like one of the simplest ones. It asks a single question, it makes a local computation in a very easy way, and it just returns a number, nothing more. But there is also maybe a more complex amplifier. It's not the most complicated one, but you can make even it depend on the number of products that are currently in the box. So if the product is already in the box, we just return 1. And the more that it might happen that the same product could appear more times in the box, but it will just deboost the actual score by a lot, because in this particular case, we decided to multiply the score by 1 over the number of times. So the more times, the more decay, the less score it got. Some boxes could get multiple products, but it would have been like the worst possible scenario in this particular case. And how did we handle it? Essentially, we decided a bunch of parameters, we tweaked them, deployed the system, we observed the results, and we asked ourselves, is this good? Yes or no? Then we repeated the loop. We added the new parameters, we removed parameters, we tweaked them, we changed the logic inside each of them multiple times, and every time we did this loop. And we were deploying on Fridays, usually, because the subscription spikes were on Sunday. So deploying on Friday is my friend. But what we were doing, actually, in this particular case, we started asking ourselves, is this training? I mean, we are actually going backwards, if you will, because we were tweaking the coefficients manually to represent what, and hoping that the results would be better at the end. This kind of felt really backwards. However, we started getting a feel of like what parameter was useless, what needed some boosting. We tweaked the coefficients manually. And maybe we were training the system. I don't know. Let's take a look at the schema of our system in this particular case. On the left, we have most of the things that we input into our system. It's not the full list, but I mean, real estate on the slides is limited. So we feed into the system each time, like the input product, the virtual product that we want to assign for, a product pool, which might be large, small, depending on the moment. Then the customer history, so we may understand, okay, this customer had this coffee 3 months ago. Do we want to send it again? Maybe. We just tweak the coefficients to make the system more reactive to that. Then the box state, like what's currently in the box. Because I didn't tell you before, but customers can have even like physical products in their orders. So they might buy a virtual product and a physical product. So we want to exclude that product, or we want to boost the same product if it's bought again. It's all intertwined together. Then we have also the customer ratings. We want to assess if a customer really liked a product or disliked it. And this all plays into like the whole logic that we are going to use downstream. Then we filter these particular coffees, like the product pool is filtered down, then it's all scored, and then at the end we have a winner with some metadata. However, this architecture is quite similar to a thing that exists already in machine learning. And by the way, disclaimer, I don't have a machine learning background, so any stupid thing that I might say is totally on me. So take this into account. But if we rename what we are just seeing, because we might just rename the inputs as an input layer. And we might want to consider the filters our own first hidden layer, where the inputs of each of the elements of the input layer is fed into in each of them. Then we might want to pass these results into a second hidden layer. And again, at the end, we have just an output layer with 1 or 2 outputs. And if we look at one of the nodes in the hidden layers, we might understand that could look like a neuron from the neural network, essentially, because it's not exactly the same. Some things are almost forced in this particular case, but we have everything in place, just in another way, because we had the coefficients that we decided ourselves instead of calculated with proper error backpropagation and gradient descent and what have you for understanding what's the optimal minimum and maximum to understand the correct coefficient. Then we had the activation function at the neuron, so which is replaced by our simple amplification method. Could be just a step function or a inverse function. Could be different for every neuron. It's not the same thing in a neural network where you usually have the same activation function in each neuron, because our thing is kind of a snowflake that's really special. And then we have also arbitrary adjustments, which is just the bias of every neuron. And so what did the question mark became? Was this doing inference? Were we doing actually inference just by running our system? I don't know. Maybe yes, maybe not. However, I want to tell you that this is not how to build a neural network. I don't know if you've understood this, but I mean, this is not how to build it, because it's not. It's just a thing that looks awfully like it. Because a neural network is, of course, a weighted decision graph where the inputs flow from one layer to the next one, gets changed, and at the end we have an output. And this is done by some small local computations with the neurons. And its shape is just the same that we built in Ruby. However, this problem could have called for proper machine learning. We didn't have any machine learning formal training, so we didn't go for the right tool for the right problem. However, maybe this was a good choice, because if we were to go for a proper machine learning solution, maybe we would have been bogged down into the real implementation, real training. And another thing was that machine learning is more a black box on the execution side. Most likely, we wouldn't been able to answer stakeholders' questions such as, okay, why is this coffee being picked right now in this particular order? With proper machine learning, maybe the system would have decided to have, I don't know, 50 parameters, 100 parameters, 1 billion parameters. I don't know. we just had maybe 48, and each of them had a name. So we could still understand the system. And this slide would have been up like earlier. So that was a mistake, sorry. But yeah, we didn't use any framework, we didn't use anything. But in this particular case, we were lucky because we built a system that solved the problem, because that's what we do as developers. We are tasked with solving problems, not like implementing particular solutions because we know that the canonical solution to that problem is like, we need to do machine learning. I mean, maybe yes, maybe not. Because sometimes you actually need to leverage proper machine learning, and like there is a place to do it. And like in this particular case, our problem was small enough that we could even reason about it. And we could define what good looked like. So if we looked at a box, a resulting box, we said, okay, this looked good, fine. And when you do proper machine learning, you need to like do it the other way around. You need to ask the system to calculate a random thing, and you decide, is this good or not? In our way, we did it the other way. And this whole story is also about the fact that maybe you, built a scoring system, and maybe it had some sort of the same thing. Maybe you just built a neural network and undersold it as a bog standard service object and call it like that. I just did the opposite and built a talk around it. Thank you.
Any questions?
Yeah, so thank you for the presentation. And my question will be, do you see any major concerns of giving the users the right to decide on the weights?
I didn't see any in production. So, I mean, we are trying constantly to tweak them because we constantly observe the system, observe the result. If we see that we see an influx of customer support tickets such as, oh, my box is too bland, I want more exploration. Why did I get this particular coffee that I disliked? And these were just the main problems that we wanted to solve. And it's a matter of iteration. You kind of wing it at the end. So you try something. If it sticks on the wall, it works. Otherwise, you change it. I don't see any major concern.
Okay, thank you. Because my question was based on the experience I worked with applications where users defined all the weights for themselves, and then based on these get the order of like propositions. So that was the reason for the question.
No, luckily we didn't experience that.
Yeah, thank you.
Thank you.
I have a question. Have you considered the optimization algorithm with a score function, actually? Because it sounds like a perfect idea for that kind of problem. In the end, you have a set of 5 elements that you need to pick from the available SKUs in stock. You have some weights. You have, like for instance, how much the user likes a certain coffee, time when it goes like out of the validation day as a product. You have things like the last time when the user drink that particular coffee. You have things like margin, obviously, because your company needs to make money. You have obviously the color as a SKU property as well. You need to consider. You don't want all the same colors in the set. And in the end, you have the score on the particular SKUs, you have a score on the set of elements, of 5 elements. And basically what you need to find out is the set that gives you the biggest score out of the available SKUs in stock.
I think that's exactly what the system is doing. We just score them, if you will, and we just pick the top one for each particular slot. We can think about maybe many optimizations that I can think of, such as, okay, if we have all equal slots, maybe we can even optimize it and doing it in one loop instead of doing it in multiple loops, but it's pretty much the scoring system. It's yeah, that's true. Fortunately, stakeholders didn't ask explicitly for machine learning, and that's why we are already deprecating this system to like a proper machine learning thing. We are starting with more complex systems.
Thank you for practical, honest talk. I have a question about little tweaks you were making manually. How did you understand that these tweaks were for the best or not? Only by customer reaction, or you had some kind of benchmarking?
The benchmark in this particular case was the product team, the operations team that was just taking a look at the results and understanding, like by vibing with the results, like, is this good? Like, would I feel good in receiving this box given this input? Yes or no? That was the benchmark. So it's a matter of taste and decisions, and that's it.
I like this benchmark, thank you.
Thank you.
It was actually my question. Yes.
Okay.
Okay, the last one.
Thank you. Did you have to pull them all into memory to run the filters, or was like some of this happening in production like some kind of like a SQL filter? Like, I don't know how many, you said they had a lot of products.
No, yeah, I mean, all in memory. Because the fun part is that we are working with Shopify, so we don't have a database to pull things from. I mean, we could have built like a sync layer to actually have all of our products into the database, but it was more of a hassle. And I mean, sync systems introduce a new kind of failure modes, and we didn't want to deal with them. So we just queried slow GraphQL endpoints and all in memory.
Right, thank you for all the questions. Thank you for all the answers. Thank you, Nicolò.
Thank you.